the most short boy in physics.
అవుతుంది సార్ ఇంకోసారి మరి
ఆయన బ్యాక్ సైడ్
Hi students, welcome back. So students, today we're going to take about 24th February's Shift 2 examination, JEE Mains paper. Students, if you would have already written your JEE Mains exam or you are going to write the exam in coming sessions, you don't worry students. As far as physics is concerned, the paper is not at all so difficult. Every year students, many students have this phobia of physics, or physics is tough. But I am saying this year physics is not as tough as you think. As far as this physics paper is concerned, on memory based questions, 14 to 15 questions are easy and some 5 to 10 questions are easy to moderate level questions, and some 5 questions to 6 questions are tough, and whereas 3 or 4 questions are having lengthy calculations. If you would have properly analyzed NCERT textbook, studied your notes and also previous year questions, you will be able to solve this paper easily, and we'll go through this journey of 2021 JEE Mains Shift 2 24th February session. Let us start. So now the question looks like this: which of the following is correct for Zener diode? Students, some of you might have done wrong in this question. You carefully see this question, students. One thing we know, where do we use Zener diode? Zener diode is used as voltage regulator. Even if high external currents also come, there will not be any change in the voltage of the circuit that which Zener diode is connected. So here students, one thing is obvious for everyone, that is it is heavily doped. It is heavily doped and operated in reverse biased. So one misconception you might have carried is reverse biased. Actually, for a PN diode, what will happen for a PN diode for reverse biased? The depletion layer will actually increase. But for Zener diode, here PN junction diode is not doped here, but for a Zener diode it is heavily doped. It is heavily doped. Due to heavy doping, there will be a diffusion current in both of the PN diodes, and because of that, what will happen is, due to heavy doping, the depletion layer will be very thin. Where is it useful, students? You might have studied this formula: electric field is equal to V, potential difference is equal to ED. So if E is equal to V by D, you see here students, in the depletion layer, because the thickness is very small, the electric field will be generated will be very higher, so that it supports the Zener breakdown. Also students, if you want to refer also, you can refer the NCERT, where it is given Zener diode is heavily doped, and also depletion layer that is formed due to heavy doping is very thin, which will produce a high electric field, students. So you can go through it. If you have done wrong, just go through it. So next question, students. So this question is also based on the very familiar concept of relation between acceleration, velocity and position, students. These kind of questions students have taken already in the one shot revision for motion in 1D and 2D, students. So now what is this question? A body is projected from origin, that is initial position is 0 at origin, with the velocity v0. Initial velocity is v0 along the x-axis, one dimensional motion, which a force alpha x square. Force is equal to how much, students? Minus alpha x square, students. So find the maximum distance from these are based on memory based questions, students. So options, if the wrong options are not as that you have seen in the examination, don't worry, students. So here v0 along positive x-axis, on which a force of minus alpha x square acting on it. What is the maximum distance from origin up to which body can go, students? One thing, distance here, position we need to understand, students. Position, how will we get students? The basic concept is if you x, v, acceleration. If you differentiate position, you will get velocity. If you differentiate velocity, you will get acceleration with respect to time. If you integrate acceleration, you will get velocity. If you integrate velocity, you get position, students. This is the basic concept that we have discussed in one shot revision as well, and we have solved 3 to 4 problems on this same concept, students. Based on the same concept, you see students here, force is given as minus alpha x square. Can we get acceleration, students? If mass is not changing here, given body is mass is constant here, students. So can I say this is ma is equal to minus alpha x square? What I am doing, trying to do, students, seeing the question, I know force. What I need to find out is distance traveled by the object. How distance and acceleration can be related, students? Distance and acceleration can be related by integrating acceleration 2 times to get the distance, and also supplying the conditions those were given in the question, students. So what we need to do, ma is equal to minus alpha x square, that means acceleration is equal to minus alpha x square by m, students. So here you might have, how can we get this velocity, students? You might have remembered this formula. What is this? Acceleration is equal to dv by dt. But students, there is another important formula. If you would have missed it, be careful to go through it. dv by dt is with respect to time. We can also write this as v dv by dx. That is discussed in one shot revision classes also, and you might have heard about it number of times. Why did I take dv by dx, students? Because here the coordinate is in the form of position. So v dv by dx is equal to minus alpha x square. If you take this equation and integrate, we will get the answer, students. v dv by dx, that is acceleration, is equal to minus alpha x square by m. So what we need to find out? Position we need to get. So integrate velocity again, find out velocity and integrate it again to get the position. So dv by dx is equal to minus alpha x square by m v dv, and send variable separable method, students. Send x to one position, one side, and velocity to the other side. What can we write here? v dv is equal to minus alpha x square by m dx, students. So integrating on both sides. What is the initial velocity, students? Limits you need to apply. Initial velocity is what? v naught. To final should be what, students? It should be body can go, means it cannot go beyond that. The final velocity at that point should be 0. So initial position is what, students, here? Origin to the final position, we are taking it as x, students. So we need to find out x here, students. So we can write it as integrating this one, x power n plus 1 by n plus 1. So v power n plus 1 by n plus 1, from that if you apply, this is v power 1, that is v square by 2, from v naught to 0 is equal to minus alpha by m is constant, bring constant outside, so x cube by 3 from 0 to x, students. So if you apply, so what? V square by students here, 0 minus v, so 0 apply in v, 0 square by 2, 0 minus v naught square by 2 is equal to minus alpha x cube by 3 minus 0, students here. So minus minus gets cancelled. We need to find out what, students? X is the final distance that the particle has reached. So x cube is equal to 3 v naught square by 2 by alpha, and then x is equal to what, students? If 3 goes that side, cube root of 3 v naught square by 2 alpha. So 3 v naught square, there is m also here, students, here 3m. So 3m v naught square by 2 alpha, students. So the answer will be first option, students. Just there is m here, alpha x cube by m 3m. So we will get the answer, students. Let us go. So next question, students. So this answer is according to it, according to the information given here, the option will be 1. So next question, students. Students, you see this question. Is there any second question you need to solve a bit? But for this third question here, you don't need to solve at all for the given options. Weight at pole is 49 Newton, then what is the weight at equator, students? So this is a question based on altitude, students. Latitude, change of latitude. What is the effect of gravity on change in latitude? So you know, students, effect of latitude study, students. So we can consider Earth to be moving like a sphere. So any particle at this point, general point, which is situated at an angle theta from Earth's gravity, we can consider that particle is experiencing a pseudo force, students. Due to this pseudo force, there will be a r omega square. Pseudo force is how much, students? M into acceleration of the frame of reference. That will be m into r omega square, students. So there will be a r, if this is theta, this will be theta, r omega square cos square theta component in this direction, students. So now r omega square cos square theta, students, g dash will be g naught minus r omega square cos square theta, student. But at here you might have studied the fundamental point, students. Equator, what is the angle? 0. So the answer will be g naught minus r omega square. At pole, the angle will be 90 degrees. So the answer will be cos 90 is 0. The answer will be g naught. So now, the acceleration due to gravity is maximum at which point, students? At the pole, students. But it will be minimum at equator, students. So here pole the value is given. So equator value definitely should be the minimum, that is which is less than the value at pole, students. So you don't need to solve the question at all, students. So what is the value that is less than 49 here, students? All the values are higher than 49, which are higher than pole, which is not possible, students. So the answer should be the value which is less than 49, that is 48.83, students here. Otherwise you can apply the r omega square value also, cos square theta, then you get the exact value as well. So next, now what is the question here, students? A light source emitting light, and if we change light from violet to red, then, students, have you studied the concept of fringe width, students? So you might have remembered the formula as well by now while preparing for examinations. That is, fringe width is equal to lambda capital D by small d. Small d is the distance between the slits, and capital D is the distance between the slits and the main screen. So beta, fringe width, this formula, did you remember the students? Fringe width is proportional to lambda here, students, because question, there is no change in the distance between the slits on the screen, there is no change in the distance between the slits. What is change is here lambda, students. If lambda is the change, so what here, students? Beta violet is equal to lambda violet into d by small d, beta red is equal to lambda red into capital D by small d. Students, here the question is only based on memory. So what you need to understand is, the question might have come from violet to red or red to violet. Only the students who have gone there can actually remember it. So if violet to red is there, if the change happened from violet to red, we know that VIBGY or violet will have the smallest wavelength among them, red will have largest wavelength. So fringe width for red will be higher than fringe width for violet, students here. So what will be the answer? If the question is violet to red, then the fringe width should increase. So here the options may be wrong, students. The fringe width should increase if it is changing from violet to red, students. question, you need, if red to violet is given, fringe width should decrease, students. That is the concept here, students. Then this is also an interesting question, students, which have come in previous year examinations as well. Find frequency of oscillation of spring block system down. Spring blocks. One basic concept you need to remember, students. Whenever spring block is there, to find out the time period or frequency, what you need to do is there will not be any effect of its orientation, students. Any angle it may be. Suppose you take this block, students, M block. If this is K, this time period will be how much equal, students? 2 pi root over M by K, students. So this, even if you change the orientation like this, and displace it by small distance x and try to find the restoring force, again what you will get is time period is equal to 2 pi root over M by K, students, because that omega will not change with the orientation in the case of a spring, students. So in all the cases the time period will be 2 pi root over M by K. So what is K here, students? K is the, if 2 or 3 springs is given, we need to take the effective spring constant, students. Here what is effective spring constant, students? This might be looking like they are in series, but this question you should practice at least 3 or 4 times before going to the exam, because you see here, students, if I displace it by distance x in the right side direction and try to find out, the same x also will get displaced in the spring as well, students. In series combination, force will be constant throughout the springs. This is the fundamental point. In parallel combination, the displacement will be constant in the both springs. Here this is effectively a parallel combination, students. Then what is the time period, students? Time period is equal to 2 pi root over M by K effective. In parallel, what is a effective spring constant, students? K is equal to K1 plus K2. Here both are equal, the answer will be 2K. This is the time period, students. If frequency is asked, 1 by time period you can do, that is 1 by 2 pi root over 2K by M, students. If frequency is asked, time period is asked, 2 pi root over M by K effective, that is 2K, students. So let us go to the next question, students. So this is also a number of times, nearly 10 questions have been asked in previous years based on this concept, students. This is a question, this might be a bit lengthy for you, but this is a quality question, students. Disk of radius a by 2 is cut from disk of radius a, find x coordinate of center of mass from origin. So what have you remembered, students? These kind of questions have asked in rotational motion as well, gravitation as well, electrostatics as well. How those questions are asked, students? In gravitation they have asked it like this. So there is a planet here or a mass of body m. Similar questions you can practice, students. Students who are going to prepare for the next shifts, you be careful or next month as well in your next JEE examination. These questions are highly important. Why? These have been asked and asked and asked a number of times. So how gravitation these questions are asked? And a solid body is there of mass m. The gravitational field due to this entire body of mass m at a distance r is some I1 is given, and a mass is cut from this sphere and asked to find out what is I2. If I1 is given, what is I2 in terms of I1? And next, similarly, a sphere which is uniformly charged, from due to that sphere at a distance of r, the electric field will be E1. And if a small sphere of radius so and so is cut from the given sphere, so then what will be the new electric field at this point? And there's other kind of questions, students, in the same concept are asked. How, students? If in rotational motion, students, the moment of inertia of a sphere, so suppose along this axis is some x. So what is the moment of inertia of the same sphere about this axis if the sphere is cut with so and so part? For all these questions you need to follow the same principle and pattern, students. Whoever has or whoever wants to appear for different exams in the next shifts, try to carefully revise all those similar models wherein how to solve those problems, students. If you want, in our one shot revisions we will explain all these models similar to this question, students. So how to solve this question, students? So what can we do is the center of mass from origin. What can we do, students? Here I will treat them as two parts here. So if the two parts center of mass is how much? m1 x1 plus m2 x2 by m1 plus m2. This is the formula. But now this mass is removed. So this one center of mass you need to find out remaining part. So remaining part, center of mass part, I will take it as some x1 comma y1. So this one center of mass I will take it as x2 y2. So both center of mass will be where, students? At the center of the disk if the entire disk is present. So that will be how much here, students? A comma 0. Sometimes this question is asked as 0 comma 0 also. Origin is kept at the center. So here, students, so what is the formula that derived from by using this concept, students? That concept will be x center of mass of the remaining part is equal to ax minus a1 x1 a2 x2 divided by a minus a2. A is what? Total area if entire system, entire mass is present without cutting anything, and a2 is the area that has been removed into x1. X is a, if entire mass is present, is uska coordinate, its coordinate. X2 is the center of mass of the removed part, and A is total area minus A2 is removed area. So now if we apply the formula from here, from this concept, so what will be the answer? Total area is pi r square, that is pi a square, and its center of mass is a comma 0, that means a x coordinate, minus a2 is what? Pi into a by 2 whole square into x2 is how much? From here, that is a plus a by 2, that will be 3a by 2 divided by pi a square minus pi a square by 4, that will be 3 pi a square by 4, students here. So the answer will be pi a cube here, pi a cube minus 3 pi a cube by 4 divided by 3 pi a square by 4, students. So now 4 minus 3, 1, pi a cube minus pi into a by 2 whole square into 3a by 2, a plus a by 2. So then 3 pi minus pi a square minus pi into a by 2 whole square, that will be how much, students? Pi a square by 4, 3 pi a square by 4. So from here, so what can we get is 5a by 6, students. This is the answer. This is an important formula. In this way we can solve a number of questions similar to it, students. So now so what is this question based on, students? This diagram is equivalent to, this question is based on the logic gates. Every year one question on an average comes from semiconductors, specifically logic gates, and you don't need, if you know the concept it's okay, if you don't know the concept also, you draw the truth table and you will be able to get the answer easily. You might take some time but you will get the answer. So by using those equations, students, what are the two equations? De Morgan laws are there, where will be A or B, negation of A or B can be written as negation A and negation B. Similarly, A, B, negation of A and B can be written as negation A plus or negation B. By using this De Morgan law, students, you will be able to get the answer, students. So now here this is not of A, negation of A, that is negation of A, this is B, and this is a symbol of OR, and this is not of OR, that means OR symbol for between both of them, and negation of not of A or B. This can be written as what? By using this symbol, not of A, negation of not of A into that is and negation of B. So not of A and not of A 2 times. Negation of A will be A and B negation. So here A and B AND gate should be there and B negation of B should be there. So what is here, negation of B is seen here, and symbol is there and A symbol is there. A will be there and negation of B will be there. By using these two De Morgan's laws, many of this kind of semiconductors problems can be solved easily. Otherwise also, if you could not remember, just apply the truth table and see what answer is matching the given answer. So next question, students, if the de Broglie's wavelength of, this is also an easy question, students, this comes under easy question, easy level question. De Broglie's wavelength you might have studied for your board exams also. De Broglie's wavelength, students, what is the value here, students? Lambda is equal to h by momentum is de Broglie's wavelength, students. So here the question is given as, this formula based questions are also many in the previous year mains and NEET examination, students. So if the de Broglie's wavelength of alpha particle and proton are equal, then the ratio of their velocities are. So we know the lambda de Broglie's wavelength is equal to h by momentum of the particle. So lambda is equal to h by alpha particle means what? Mass of alpha and velocity of alpha. Similarly, for proton, lambda of proton is equal to h by mass of proton into velocity of proton. So what we need to do, students, here, so both are equal, they are saying. So we can equate both of them and find the ratio of their velocities. That is, if both are equal, h can be cancelled. So that is 1 by m alpha v alpha momentum of alpha particle is equal to momentum of proton particle. So we know ratio of velocities, that means ratio of velocities of what? Alpha to proton. So v alpha by v proton, and taking this side will be mass of proton by mass of alpha. What is mass of proton if we take 1, because in nucleus there only one proton. So mass of alpha is what? Alpha particle is nothing but doubly ionized helium atom. This you might have studied. So He2 plus, helium has 2 protons and 2 neutrons, so total mass will be 4. So that means velocity of alpha to velocity of proton is 1 by 4 will be the answer, students. Next, so this is also, it might look like bit complex, or this is looking like complex, but you need to know 2 fundamental points, students, while going through. Many times students think that these questions on inductor and capacitor are difficult, but they are not difficult, students. Why students? Here the switch S is closed at t is equal to 0. Find the current given by battery just after closing this, the switch. Whenever you see these words, consider just after switching the switch, you consider the question is going to be mostly easy. Why? Just after, why it's easy, I will tell you, students. There are 2 components you might be here, capacitor and inductor. I will explain you this concept, students. Capacitor and inductor. Capacitor offers no resistance when just the switch is closed in a circuit. Suppose there is a circuit of this sort, you understand this concept, students. Here it will be useful for any question of just after closing the switches, that basic fundamental. So if suppose a battery is there, capacitor is there, some resistor is also there, some example I am giving. So if switch is there here, suppose here switch is there, students. Here, so when switch is closed, just closed, capacitor offers 0 resistance, because capacitor wants to get charged. So current will travel to this wire without any problem, students. What will happen? You can remove the capacitor and solve the problem like this. Just you can remove the capacitor and just short circuit it, means matlab connect it with the wire just after the switch is closed. But in case inductor is there, students, the same situation. In case inductor is there, the current will be how much? V is equal to IR. But if inductor is there, inductor offers infinite resistance to the current. So because immediately when the switch is closed, it offers a opposite EMF of minus L into di by dt. So initially that should be equal to EMF of the battery or potential difference across the battery, so that what will happen is the inductor will not allow any current to pass through the circuit. If inductor is given, how to solve the problem, students? Just inductor is given, how to solve the problem, students? This is an open circuit, it acts as an open circuit. Students, for capacitor what you need to do, you can connect the wires and solve the problem. For inductor, if just after the question switch is closed, then you can treat it as a open circuit because it offers infinite resistance and will not allow any current just immediately after the switch is closed. This is a fundamental point, students. Many questions actually students have left these kind of questions seeing the diagram to be complex, but these questions are easy if you know this fundamental fundamental principle. So here just after the switch is closed, inductor offers infinite resistance here, students. So because it will create an opposite EMF equivalent to the potential difference across the battery. So this also will offer, students. So we can consider these two circuits as open circuits here. So here current will not flow through these circuits, current will flow only through this circuit. So if we read out this circuit after the switch is closed, this will be 2 ohms, this will be 2 ohms, this will be 9 volts. So 9, if you draw the basic Kirchhoff's law equation also, you will get 9 is equal to I into R, that is 4, I is equal to 9 by 4. The answer you can solve by it, students. 2.25 is the answer. So this question might be looking complex, but this is easy, students. So let us, for which of the following transitions in hydrogen like atom of the frequency of emitted photon will be maximum? So what is happening here, students? Whenever hydrogen atom transition is happening, if the transition is happening from, this question is also based on Bohr's atomic model, students. If the transition is happening from higher orbits to lower orbits, the higher orbit electron energy level will be higher, so energy will be released in the form of photons. So the amount of energy it gets reduced for the electron, that amount of energy is released in the form of photon, students. So now which transition will have large amount of photon? Frequency is asking, energy of a photon can be written as h mu, frequency will be higher for higher energy. So higher energy shift we need to understand. One thing you can solve by calculating this as 13.6 into 1 by n1 square minus 1 by n2 square, you will get this answer as 2 to 1. But also you can substitute all the values and compare, but also if you would have known the diagram, you know the energy levels, minus 13.6, minus 3.4, minus 1.51, minus 0.85. These values I recommend you students to remember. Why? Because the difference between them is 10.2, which will be higher. The difference between this first and third orbit will be minus 12.1. So these values, if you remember, students, many problems from modern physics, while the jumping happens from first orbit to third orbit to first orbit to third orbit to second orbit, the problems will become easier for you if you remember these values. This diagram is given in NCERT textbook also, you can go through this diagram, and many problems similar to this question have come in the previous years as well. So if you would have practiced those questions, this question becomes simple. Students, I hope you have enjoyed these questions, and the rest will be followed and taken care by Vijay sir will go through them. I hope you have enjoyed. We'll meet again, students.
And so here students we have, and we will start from the problem number 11, where we have from the problem number 11, which is somewhat an easier problem to solve. So here he has given two charges are fixed at a separation of 2d. So here there are two charges which are being separated by a distance of 2 times of d. So let us take these two charges. These two are the two and negatively charged particles separated by distance of 2 times of d. So let it be d and d. Next, at the middle of these two charges and a proton which is a positively charged particle is free to oscillate. Mass of the proton is m suffix p and the charge of the proton is small e. So he has given the mass of the proton m, small p, and the charge is small e. Now if the proton is slightly displaced perpendicular to the line joining of charge, then find its angular frequency of the oscillation. So here angular frequency means you have to find the value of the angular velocity or the angular frequency, the omega, where you have the relation omega is equal to root over k by m. Here k is a constant, as here you have taken the two charges, the constant in between the two charges is k, where k is equal to 1 by 4 pi epsilon naught, which actually depends on the medium. So here in this case, when you take two charges, their constant depends on the medium in which those two charges are present or existing. So that is what you have to do here to find the value of k. Then obviously you can find the value of the angular frequency what he had asked. So let us draw a diagram here. Two negatively charged the electrons and one proton, let it be here. So these two charges are at the same distance because it is on a line joining or passing through the center of these two charges and perpendicular to them. So this charge proton, that is plus E, is at the same distance from these two charges. So here let this be small d and this be small d, and let this distance here, the perpendicular distance, be y. So first you have to find these distances. So this distance would be the distance from minus q to E, where you represent it as r, is equal to square root of y square plus d square. Now you have to find the total force acting because of these two charges at the charge present, which is the positive charge here. So to find that, you have the Coulomb's law obviously, but here if you understand that this is positive and this is negative charge, so the force in between these two particles would be in this direction, and this is also the same. So these are the two and opposite charges, so the force will be in this direction. So here the net force, here it is exactly the perpendicular bisector, so this angle would be equal with both the charges. So let it be some theta and theta. So here the net force would be exactly the center line passing through the charge and positive charge. So here you can write the total or the net force F net is equal to 2 times of, because this is also causing the charge and this is also causing the charge, so that is 2F cos theta. So this is the force acting, and let it be F1, let it be F2, and this F1 is equal to F2 is equal to F because of the same magnitude of charges obviously. Next, these two causes the resultant force in this direction. To get in this force, this becomes actually F1 cos theta and this becomes F2 cos theta. As F1 is equal to F2, you can write 2F cos theta. So 2 times of F, as you know the force in between two charges, K into Q1 Q2 by R square. So it is and let it be, here it has given two charges, so let us take this as E and E itself. So E square by R square, here R is equal to what we got here, R is equal to square root of y square plus d square, but it is R square, so y square plus d square into cos theta. So cos theta is equal to y by root over d square plus y square. So from this you can write obviously 2k into E square y by y square plus d square whole power 3 by 2. So this is the value of the net force acting. As you require here to find the value of angular frequency omega is equal to root over k by m, you need to take the value of k from here and you have to substitute in this equation, and which is being divided by m, then you will get the total equation for the angular frequency. So that is, let us see here, omega is equal to root over k. So from this you can write k is equal to f net into or you can take this as into y square plus d square whole power 3 by 2 by 2 e square y. If you substitute by m, then you will get like e square by 2 pi epsilon naught mp. Here mp means the mass of the proton by d cube. So this is option 1. So this is what we have done here exactly. So what we got 2k e square y by d square plus y square whole power 3 by 2. So from this you will got the resultant force. So you have substituted in the value of k, where from this equation, if you compare this equation, you will get k is equal to e square by 2 pi epsilon naught d cube. So as the angular frequency omega is equal to root over k by m, you have taken the value of k into this equation by m, you will got the it is equal to and root over e square by 2 pi epsilon naught m d cube. So here in this problem he is asking which of the following and represents the travelling wave. In general, and a travelling wave is always represented in the form of sine or and cos wave, where it is represented as y is equal to a sine or a cos t minus t naught or t plus or minus t naught, where t naught is the time instant where you have to find the position of the wave. So here always you know that speed is equal to the distance by time or the displacement by time. So from that you can write the time is equal to distance by speed. So here it would be always in the form of f of t plus or minus t naught, but as the time is represented in the form of the distance by velocity, so t plus or minus x by v, this will be the equation for the travelling wave. So here in these equations, if you compare, this is the equation which is in the form of x f of t plus or minus x by v. Next, in the 13th question, if the soft iron is placed in the presence of a in the presence of the uniform magnetic field, so what happens to the size of the domain? So what happens when you place a ferromagnetic material in the place of a uniform magnetic field? Here you have heard of, you may have heard of the concept like the domain spinning. So when you place this ferromagnetic substance in the presence of the magnetic field, here these domains spin, but when you haven't applied the field, these domains orient in the random direction. But when once you apply the field, those dipoles which are close to the direction of the applied magnetic field, those spin faster. So those domains will have some larger areas. So obviously here the domain area will increase, and also the orientation will also change in the direction of magnetic field. Next, you have the 14th question. He is asking which of the following and correctly matches. First is X-ray. So X-ray is only because of these negatively charged particles called the electrons traveling into the inner orbits of the atoms. So it comes under the inter-electron transition, X-ray. Next, gamma ray. So gamma ray is a sort of the nuclear radiation. So it comes under the radioactivity. The third one is the radio wave. So radio waves are generally used for the long distance and transmission. So these are used in the areas which mean antennas. So that is the rapid acceleration and deceleration of the electrons in the antennas causes the production of these radio waves. Second, the microwaves are being caused in the magnetron. So from this you can see it is option 1. So here in the problem number 15, he has given a PV diagram. That means he has given a graph in between the pressure and volume, and which is shown in the graph here. He has shown that AB is an isothermal process, that is it is maintained at the constant temperature, and during AB the temperature is T and the gas is 1 mole. Here the quantity N, small n is equal to 1. And next he said BC is isochoric process, that is it is done at constant volume. It is done at constant volume. Ci is the adiabatic process, the total heat energy will remain the same. So the coefficient of the adiabatic exponent is gamma. So he is asking what is the total work done by the gas. So here you have to split the graph into 3 parts because it includes 3 processes. First, take the first process from A to B, where it is the isothermal process at constant temperature. So what is the work done during the isothermal process? As you know, it is work done from A to B, nRT ln V2 by V1. So here N is, here he has given it as only 1 mole. So simply you can write RT ln V2 by V1 from the process of A to B. At the point B, the value of volume is 2V. At the point of A, it is V. So 2V by V. So it is RT ln 2. Next, from the graph of B to C, here this graph is at the constant volume 2b. So here in this process there is no change in the volume. So here it becomes P into and delta V, where the delta V, the change in the volume, is 0. So the work done during the process from B to C is 0. Now let us take from C to A, but he is asking in terms of the coefficient of the adiabatic exponent gamma. When he is asking the work done in the adiabatic process in terms of the coefficient, then you have the work done from C to A is equal to the final value P2 V2 minus P1 V1 by 1 minus gamma. So here you have the value of P2 V2 at point A, where the pressure is P and the volume is V. So that becomes P into V minus P1 V1 at point C. P1 is P by 4 and V1 is 2V by 1 minus gamma. So from this obviously you can write PV minus PV by 2. So that is obviously PV by 2 by 1 minus gamma. So PV by 2 into 1 minus gamma. Here you can write PV is equal to RT, because the number of moles in this process is also 1. So these are the three work done. You can add this to get this option. 1, the work done from A to B, the work done from B to C, and the work done from C to A itself. So, and this is exactly what we have done. Next, in the problem number 16, he is asking the time period of the oscillation of a simple pendulum is given by T is equal to root 2 pi square root of L by G, where L is the length of the pendulum, G is the acceleration due to the gravity. So he has given find the percentage error in the value of G when T is 1.95 and L is equal to 1 meter, given the least count is 1 mm and least count in T is 10 millisecond. So those can be the sort of the errors in those values, because that is the least count. There can't be the error actually larger than that, because it is the smallest value that we can measure with the help of this instrument. So find the percentage error in G. So first you have to write this equation in terms of G, the acceleration due to gravity, as T is equal to 2 pi root over L by G, as you have to write in terms of G, because he is asking the percentage error in the value of G. So obviously from this equation you can write, first let us solve this. T square is equal to 4 pi square into L by G. So from this equation you can write like G is equal to 4 pi square L by T square, where 4 is constant, pi is constant. So there is no need to consider these two quantities in the dimensional analysis or while calculating the percentage error, because these are the constant values. There is no change in those values. So there is no possibility for the error occurrence, because those are fixed values. Next, there is G is proportional to L by T square. So the value of error in G and depends on the errors in L and T. So the percentage error in G, delta G by G into 100 is equal to the percentage error in L, delta L by L into 100 by T square. So this is the division, and you have to consider the multiplication and division in the same way while calculating the percentage error, but it is T square 2 times. So it is 2 into the error in the value of time period of oscillation. So this is the formula what you have to consider here. So you have to find this obviously. Then what is the change in the value of L? He has given 1 mm by the actual value of L 1 meter into 100 plus 2 into change in the value of time period, that is given as 10 millisecond by the actual value of time, what it is 1.95 second. If you substitute those values into this equation, then you will get the resultant answer. So change in the value of L is 1 mm, so let it be 10 to the power of minus 3 by the actual value of L 1, okay, into 100 into 10 square plus 2 times of the error in the value of T is 10 milli. So 10 into 10 to the power of minus 3, that is 10 to the power of minus 2 by the actual value of time, what he has given as 1.95 seconds into 100, because you have to convert in terms of percentages. If you solve this, this is like 10 to the power of minus 1, that is 0.1 plus 10 to the power of minus 2 and 10 to the power of minus 2 get cancelled, 2 by 1.95, it is obviously almost is equal to approximately equal to 1. So it is like 0.12, sorry, it is like 1.2. So it will be exactly 1.1. So 0.1 plus it will come like 1.12 will be the option which is closest to this value, 2 by 1.95. So it will be under like 1.02 exactly, to be exact. So 1.02 plus 0.1, which is 1.12. Here it is option 3. Next, let us consider the problem number 17, where he has given two statements. In the first statement, he has said that a transistor can be made by using two PN junction diodes connected in series. Here in this statement, what you have to understand is, while we are talking about the transistor, in general, we say, okay, you can consider the transistor like the combination of two diodes. Okay, only you can consider, but in reality, you can't make a transistor by joining two diodes. Why it happens is, first you have to understand the functioning of the transistor to actually give the statement why we can't use a transistor as a combination of two diodes, because a transistor contains three parts, mainly the emitter, base and collector. So in this the emitter is very highly doped, base is very lightly doped, and the collector is also very highly doped, but not as high as the emitter. But here the size of the base is so small. First you have to consider these things. While what happens if you connect two PN junction diodes? Now let us see. So two PN junction diodes, if you connect in series, here both these parts have the same size. That is, if you consider, or if you connect these two parts to form a base, here the size of the base would be very large. Well, but in the case of the transistor, the size of the base, which is very small, because in a transistor the base acts as a channel from the emitter to collector, but not it in this case. Here the doping level of the base will also become equal to both the emitter and collector. So here it is not possible to connect two diodes and make it as a transistor. And the second statement, beta is the ratio of IC by IB. So beta is the gain in the current value when you connect the transistor in the common emitter configuration. So in the common emitter configuration, the gain, so the current gain is the value of the output current by the input current, which is IC by IB. So here the statement 1 is false and statement 2 is true. Next, in the problem number 18, he has given and one X-ray tube, in which he has given a voltage of 1.24 mega or and million, because both the mega and million gives the same value, which is obviously on 10 to the power of 6. So you have to consider the accelerating voltage V to be 1.24 into 10 to the power of 6 volts. Find the cutoff wavelength. So what you have to do is, you have to understand that here the voltage or the potential is equal to work done by charge. So work done is nothing but the energy, which is hc by lambda into q. So from the Max Planck's and quantum theory, as he is asking the value of find the cutoff wavelength, that is, he is asking the lambda minimum. So from this you can write the lambda minimum is equal to hc by qv. So you have the value of h, which is obviously the smallest known physical constant, which is 6.6 into 10 to the power of minus 34, and c, the speed of light or the velocity of light, 3 into 10 to the power of 8, by q, what he has given the particle to be, obviously it is X-ray, so you have to consider the electron, which is 1.6 into 10 to the power of minus 19, and the value of the voltage, applied voltage, which is 1.24 megavolts or 1.25 million volts. So 1.25 into 10 to the power of 6. So this is the calculation part, what you have to do or what you have to understand here. So the major thing is, from the most basic formula of the voltage is equal to work done on the charge. So here you can consider the work done in terms of the wavelength, that is, you can use the Max Planck's quantum theory. From this you can write is equal to hc by lambda into q, as he is asking this value of lambda. Lambda is equal to hc by v into q, and you have substituted those values and you will get the option 10 to the power of minus 3 nanometers. Next problem, problem number 19, which of the following curve represents the radiation between the velocity and also the displacement of the particle performing simple harmonic motion? So here, in case of the simple harmonic motion, you know the basic formulas for finding the displacement, the velocity and the acceleration. So here the velocity is equal to omega into root over a square minus x square. So A, for example, if you want to find the value of the acceleration A is equal to minus omega square into x. So V is equal to omega into root over a square minus x square. This indicates the path of the ellipse. This graph indicates ellipse. So here there is option 1. So it is the ellipse, option 1. Next, in the problem number 20, which of the following is most appropriate regarding the Bohr's model? So first here what you have to consider is the Bohr's model, but the first main quantity what he is asking is speed, the frequency and the Coulombic force of attraction and the kinetic energy. In these 4 statements, what is true? So first you have to check each and every one. So to understand that, from where these all comes from the radius. So first you need to have the value of the radius of the Bohr's orbit, where it is r is equal to n square h square epsilon naught by n square h square epsilon naught by pi m z square. From this you can find the value of the speed or the velocity, where from the Bohr's orbit here, as you know that Bohr's orbit is been quantized in terms of the angular momentum. MVR is equal to nh by 2 pi. So here if you see MVR is equal to nh by 2 pi. From this you can write the speed or velocity V is equal to nh by 2 pi mr. So here you have the radius. Substitute this value of radius into this equation. Then you will get z square by 2 nh epsilon naught. This is the speed or velocity. So he has said that speed is proportional to z by n. So here obviously here speed V is proportional to z and n. So it is true. Next, let us consider the frequency of oscillation. For the frequency, first you need to have is the time period, or else you should have the angular frequency. So omega is equal to 2 pi f. So if he is asking the angular frequency or simply the frequency of oscillation, f is equal to omega by 2 pi. But where do we have to find this angular velocity or the angular frequency? You have the relation in between the linear velocity and angular velocity or the angular frequency. V is equal to r omega, that is omega is equal to V by r. See here, now you have the value of V and r and substitute into this equation, where you will get the value of angular frequency. So that is like V is z square by 2 nh epsilon naught into the value of r, where it is n square s square epsilon naught by pi m z square. So this becomes pi m z square by 2 n square h square epsilon naught. So from this, what are the terms that will cancel out? We shall look it after first. So here z and z remain same. So that is z square, it will be okay, e square and e square, e power 4. So we have considered z and e values. So obviously pi into m by 2 into n into n square, n cube, h into h square, h cube, epsilon naught into epsilon naught square. This is the equation for the angular frequency omega. So if you see this from the angular frequency, as he is asking the relation between only z and n, so take the values of z and n itself. So angular frequency omega is proportional to z square by n cube. Omega is proportional to z square by n cube. So let us take now frequency. Frequency is directly proportional to omega, and omega is proportional to z square by n cube. So obviously frequency is proportional to z square by n cube. So here it is wrong. Next, if you consider this, the Coulomb force of attraction in between the nucleus and also the negatively charged particle, the electron. So here what you have to do this to find this Coulomb force of attraction. So obviously to find the force in between two charges, you have the Coulomb's law, what he has specified here. So F is equal to K into Q1 Q2 by R square. As he said, it is Bohr's model. So there should be one nucleus present at the center. So what is the charge inside the nucleus? So the charge inside the nucleus depends on the number of the protons, where the charge of the proton is equal to charge of the single electron. So here you can consider the charge of the nucleus Q1 to be Z into E. Z indicates the number of protons and E indicates the charge of each proton. So the total charge inside the nucleus is Ze. And there is only one electron, because this Bohr's model could be only applied to single electron species. So you have to consider one electron. So Q2 is equal to E. Now let us substitute these both into this equation. Here k is constant and no one is to and consider that because he is asking the relation of the Coulomb force and Z and N. So Coulomb force Z into E, okay, this is E, okay, R is n square h square epsilon naught by pi m Z square. So n power 4 h power 4 epsilon naught square by pi m Z square. So again whole square. So pi square m square z square e power 4. This is the thing what you are getting here. So from this equation, Coulomb force is proportional, here z is there, z square, so obviously z cube proportional to z cube by n power 4. So this is right. Next, consider the kinetic energy. Here the kinetic energy is so simple. After doing all this, then it is simply half mv square. So half mass into v square, where we have found the value of the velocity just now. V is equal to z square by 2 nh epsilon naught. So proportional to v square, proportional to z square e power 4 by 4 n square h square epsilon naught square. So from this you can write here the kinetic energy is proportional to z square by n square. So this is also correct. So here the correct option is A, C and D. So that is option 1 and B is wrong. So and from the next problem, here Mr. and the Shivashankar sir will take over the class. So thank you for the class.
Hello students, so I hope up to the question number up to 20 you have clear, as two sirs have already explained these concepts. From question number 21 we are going to explain this thing, and if you see this question and if you're a regular follower of Skyget app, so there we were doing the crash course on the modern physics. I was especially teaching modern physics, and in that modern physics, if you remember, if you're a regular follower, so that day I told you and I have highlighted you that this relation or basically direct proportional relation can come in your exam, and that exactly has appeared in your exam. So just need to be careful, because whatever we are teaching, that is definitely very useful, and you will be surprised that so many things have directly appeared in your JEE exam. So let's start the question number 21 and let's see how to do that. Question number 21 seems super easy. Two object of mass ratio they have given the kinetic energy ratio to be A to 1. Their momentum, okay, and their momentum is same. So if you see what they have given mass ratio to be 1:1, 1:2. So m1 over, let's solve the solution. m1 over m2 they have given is 1/2. They have given the kinetic energy ratio. So k1 over k2 they have given, and that is A over 1. Second thing they are saying, and the last important thing saying, that momentum is same for the both of the object. It means P1 is equal to P2. These are the different equations they have given, and out of that they are asking the simple relation based question, and they are asking for the value of A. So if you remember guys, few days back we have done the kinetic energy is equal to half of mv square, and momentum is mass into velocity. So the kinetic energy, you can say, if you place like this, it's going to be mv times v, and from this relation velocity can be your momentum divided by mass. This is the relation we already know. So I can say that it's going to be half of p times, and v will be p over m. So this is going to be, this is going to be p over m. So this is the relation we have. P square over 2m will be the kinetic energy. This is already we remembered. So if you remember this relation, based on this relation you can compare. Since in the question they have already given that momentum is same, it means this the upper value is a constant. Only these two are values which are inversely related to each other. So I can write one relation directly from here, that they will be kinetic of 1 over kinetic of 2 will be, since they are inversely related, is going to be m2 over m1, right? And we know already that k1 over k2 they are assuming that it's to be a over 1, and mass m1 over m2 is given, that is 1 over 2. So just opposite of that value will be 2 over 1. So from here if I compare, that a is going to be 2. This is how you have to solve your numerical. The question was super easy, the formula based question, only you have to use the simple logic and get the answer. Okay, so your solution has to be 2. That's okay. Now in this question we are going to do this also. This question is also very good question. They are saying that by applying a force, a rod is there along its axis. So it means there is a rod and they are applying the force like this. The rod get elongated by this value. So when they, let's suppose for a second, this is A, this is L, and this their area is A. Now they are saying when they are applying the force, because of by the application of the force, rod get this much your elongated. So this much is the change in the length. Elongated means final length minus original length. Okay, this much. So if you remember the relation, this question belongs to the your property of solids, right? And there we have studied the stress and strain. So if you remember that stress is equal, let's suppose the solution we will solve from here. What are the given? So Young modulus times E, force over area equal to Young modulus times change in length over original length. This is the equation we already know, right? So whatever their equation may be, whatever the diameter may be, I can place like this, is going to be y times this change in the length they have given as 0.04 meter divided by this your original length. Okay, so this is important relation that we have. Now in the second case they are saying that if the length of rod is doubled, it means that what is going to happen, that L2 will be twice of L1. If I assume to be this to be L1 like over here, so L2 will be twice of L1, and diameter is also doubled. So diameter is also doubled means D2 will be equal to twice of D1. Now what happens, the same force is applied, the force they remain constant. So what they are saying, that whatever the new change in the length is this much, x into 10 to power this value. So the change in length in this case L2 is your x into 10 to power minus 2 meters. This is the change in the length they have given. Now if you remember, this is your wire and the cross section of the wire is circle, and for the area of the circle is pi into d square. Pi or square, right? Pi into d square by 4 you can say, right? So pi d square by 4 because r by 2, and then you will do that, right? So this is the formula that we already know, that there is no such a confusing thing. Now if you see boss, this is initial area in the case when the diameter will become twice. So in the case when the diameter will become twice, this is going to be 2 times of d square by 4, and I guess I will get 4 times a into d square by 4. So I can say the second area is 4 times initial area, right? So over here I can say that A2 is boss my 4 times of A1. This is what we know. So if I place all the value in the new equation, so what I'm going to write, if the same equation I use, so let's suppose F2 over A2 is going to be Young modulus over change in length in second case divided by your whatever the length may be, or L2. Now F2 and F1 is the same, we already know that, so we don't need to worry because this is going to be F. A2 in this case just now we told that A2 is going to be 4 times of A1. Young modulus will be same. Change in the length, we need to remember how much the change in length will be divided by L2. L2 in this case they have already given, that is twice of L1, right? So I hope you are able to understand. So from here what we can do, if I divide this equation and if I divide these two equations, what I'm going to divide, I will be able to divide this value. This is A1 will be divided, Y will be divided, L1 will be divided. So I am going to have the value, whatever the value will be left will be 1 over 4 equals to change in the length of 2 divided by 0.04, and I guess it will be multiplied by 2, right? Because this is 2 over which is already left. So from here the change in length is going to be 2 by 4 into 0.02. This will be 1 over 2. So right, we are not leaving anything. Okay, let me check again. This is my 4. Yes, we are correct. Okay, okay. So this is going to be 4 times of area. This is going to be twice of diameter. This is your twice of length. So if you place the value in correct order, you are going to get your answer, and that has to be this value is equate. If you try to equate this value will be around this has to be 0.4 will go over here and 2 will go over here. So this has to be twice into 10 to power minus of 2, right? And from here you will get your value to be equal to 2. This is how you will able to solve this solution. Understand? Okay, now we are going to go for the third question, which is 23. A rod of length is this much, mass is given, bent to form the regular hexagon. Okay, so they have given one rod is there and its mass is m and the total length is l. Okay, so what they're doing that to form the regular hexagon. So what they have done, they have break this rod into the 6 part and they have formed one regular hexagon. Hexagon means the geometry which has 6 sides, that is called the hexagon. So out of that, whatever the length may be, they have changed their shape and got their length. Now what they are doing, find the moment of inertia of the hexagon about the axis perpendicular to the plane. Perpendicular to the plane means this is the plane of the hexagon, and when they say perpendicular means they are talking about this axis. Okay, the pen, if you see the pen is going inside the screen, right? So they are talking about this perpendicular axis. Understand? So we are going to find out how to find all these things. So now see very carefully how we can get your answer. So for example, if this is a mass of m and length of l, if you divide into 6 parts, okay, if this rod is divided into 6 parts, so their mass will also be divided into 6 parts if we consider to be uniform, and if we are assuming that there is no error, so this mass will be this mass of each the part will be m by 6 and l also become l by 6, right? Now if you are going to join this thing by cutting this rod into 6 parts, and if you try to form one hexagon, so you can place this hexagon like this, okay, and you want to find out the moment of inertia of this block about the center. So how can you do that? This is m, this is one rod, this is 2, 3, 4, 5, 6. If you add all them, you will get the total mass to be m, and if you add all the length of that, you will get the length to be l. Now you want to find out how much is the moment of inertia of this thing. So what I can say, if you remember, what is the moment of inertia of the rod about this axis? This axis or the perpendicular axis, whatever axis you want to say, this axis or this axis which is going inside the screen. So about this screen, the formula is ml square by 12. This is the moment of inertia of this block. So what we can say that, for example, if I want to find about this axis, I can easily say that if you remember in hexagon, if your total side, if the total angle is 360 from here, and how many triangles we are getting? We are getting this is 1, 2, 3, 4, 5 and 6. We are getting total 6 number of the triangles. So if you divide the total angle to be 360 divided by 6, we are going to get internal angle will be 60 degree. It means that between two sides this angle is going to be 60 degree. Okay, so about this center, let's suppose this is 60 degree. So and their length will be, length is already we know that is L over 6, this is L over 6, this is L over 6. Now since this angle, total angle is 60 degree, about this axis we know that I will be basically ml square by 12, but in this case m has become m by 6, L has become boss, L has become your this thing L over 6, this is going to be L over 6 square divided by 12. This is going to be the moment of inertia for this, about this rod which is already broken into 6 parts. So I can say moment of inertia of one block is going to be m by 6 into L square by 36 divided by 12, and if you just get this relation, this is going to be ml square by 6 into 36 into 12. This will be your moment of inertia of one block about this axis. Understand? Now what you have to do, this is the moment of inertia about this plane for this rod. Now they are asking for moment of inertia about this axis. So what you have to do, you have to use the perpendicular axis theorem, and if we are talking about perpendicular axis theorem, so this angle will be 30 degree, right? So how to find out this length? This length you can get from that, since this is 30 degree, you can use the cosine component, and this length will be L by 6 cosine of 30 degree, which is L by 6 root 3 by 2. This is the length which we will get for this part. Now if you place this value, and we know the perpendicular axis theorem is Ixx is equal to your I plus m into d square. This is your perpendicular axis theorem. So I can say that this value is going to be ml square by 6 into 36 into 12. I'm not going to multiply, plus if I use this value, this is going to be the length m into the, and this mass is again going to be m by 6 into L is your root 3 times of L divided by 12 square. This is the moment of inertia of one rod about this axis, and if you multiply by the 6, you are going to get your result. This is how we can find out the moment of inertia about this whole system about this center, which is going, the plane which is going perpendicular to this plane. So if you solve all the question, you are going to get that it will be your 0.8. So I hope you understood the process. Now two cars A and B both are moving toward each other. Very good. Okay, two cars are moving toward each other. It means this is your car 1. Okay, this is the car number 1. Over here, let's suppose there is one smart boy here, and there is, let's suppose there is smart girl over here. Okay, this is smart boy, smart girl. Okay, it will look better. Okay, now the car A and B both are moving toward each other with a speed of this value. It means this boy is moving with 7.2 kilometer per hour, and this is also moving toward this value with this speed. Now source A produces a sound of frequency this much value. So it means the frequency of A produced is 676 hertz. Now find the beat frequency heard by the person who is sitting at A. Now how does it happen? How it will work? Okay, so they are asking that you have to find out the beat frequency heard by A. Now what is the beat frequency heard by A? Try to understand this thing very, very carefully. Now one frequency which he will able to hear is that since he is releasing the sound, he is a source and he has a speaker. He has a speaker, and from this speaker waves will be traveling to him, right? So wave will be traveling to the B, or girl will able to hear the sound from A, and after that, after striking the car or the part of the car, again that sound will travel back in that direction, and that will be heard by him. So he will able to hear two sounds. One is the created by himself, and other is the sound which is coming after reflection from B. So how to solve this question? This is super easy. So for example, for a second you can assume this is to be your source, and for a second let's suppose it is not moving. In that case, relative velocity will be just added of those two. So what I can say in that case is that frequency heard by B is going to be V plus U divided by V minus U times frequency heard by A. Okay, this is the frequency from Doppler effect. We know this formula. Now in this case we will act as a source to be A, and what kind of frequency that heard by A will be the after reflection from B, and that is going to be again that V plus U divided by V minus U times frequency of B. So in that case we will assume that source is B. So you can place this value over this equation. So F heard by A in the second case will be V plus U divided by V minus U and square of that value into FA. This is the frequency of sound which is heard by A after coming from B. Now beat frequency is what? Beat frequency is F2 minus F1, the difference of two frequency which you are hearing. So you can easily place, so beat frequency of A will be, boss, V plus U divided by V minus U square of FA minus your FA. Understand? So if you just take out these two values and let me solve this equation over here. So the beat frequency is going to be V plus U divided by V minus U whole square minus of 1 into frequency of A. Now since if I take the LCM, this is going to be V plus U square minus V minus U whole square divided by V minus U whole square into frequency of A. Now from here what you can observe, this is to be A, this is to be B, so you can use A square minus B, which is A plus B, A minus B. So this is going to be V plus U plus V minus U, and this is going to be V plus U minus V minus U. This will become minus and this will become plus U divided by V minus U whole square into frequency of A. So from here you can eliminate this U will cancel out, V will cancel out. So beat frequency is going to be V times U twice into V minus U whole square equal to frequency of A. And from here, for a second, if I assume that since the V is the speed of sound, and speed of sound they have given 340 meter per second. So this is the 340 meter per second. Speed of sound is 340 meter per second, and the speed of their vehicle is how much? That 7.2. So if I convert the speed of the, let's suppose the vehicle, okay, speed of the vehicle is 7.2 into 5 by 18 to convert into meter per second. This is going to be 0.4, and this value is going to be 2. So in the first case, your speed of the sound is around 340 meter per second. And in the second case, your vehicle is moving with only 2 meter per second. So if you try to subtract this value will be very, very high. So for a second, what you can assume that 2 times of V into U divided by V square into frequency of A. Why I am able to neglect that value? Because even if you don't want to neglect, you don't need to do that. But why I am neglecting? Because one value is 340, other value is 2. So if you subtract only 2, that is not going to make big difference. So from here we cancel out. So we are going to have 2U times over V into FA. And if you place the value, you try to solve the answer, you will get your solution. This is what we have to do in this case. And after solving everything, you are going to get 16. This is what you needed to follow that. Okay, let's see the question. A point charge Q okay, the point charge Q is placed at the center, okay, at a distance 6 centimeter from the center of a square of side this thing, okay. And they are asking the electric flux passing through is x into 10 to power of 3, okay. Then they are asking what should be the value of x. So if you remember, if you see this diagram and if you try to draw one square like this, okay, if you try to draw this square like this, okay, now why I am drawing this square? The reason, there is some reason. So what is the reason? The reason is the Gauss law, and Gauss law says that total flux coming out from the closed surface is your charge over epsilon naught. Whatever your charge is, just divided by epsilon naught. So in this case, if I want to cover these things, you can see there is two method. Otherwise, you calculate upon the charge how much charge will be sending the flux. But if you say there is a one charge which is placed inside the square, and in every square has 6 face. So from each face, total number of flux which line will be coming, that will be equal. right? So whatever the flux line will be coming from here, that will be the same from this case as well, for downward as well, for all directions going to be same. So in that case, what I can say that because of Q charge, total flux is coming from 6 phase and that is equal. So can I say that from one phase total flux that will be coming, that will be because of the 6 by Q charge, right? So in that case, this will be your Q by 6. So I can place the flux will be Q by 6 into epsilon naught. You can place the value of epsilon naught, which is basically Q they have given, that is 12 into 10 to power of minus 6 coulomb divided by 6 into 8.85 into 10 to power of minus 11. You can take over here, then you solve this value and you will able to find your answer. If you solve all the value, and you have to equate equal to x into 10 to power 3. So since this is your 11, it will go over here, you just try to cancel out, this is 0.05. So finally after that you will able to find, you will able to get your answer, and that x has to, simple equation, you have to equate this left side to the right side and you will able to cancel the things, and final answer will be 226. Now there is a cylindrical wire of radius this much, conductance is given, okay, very good. If the potential gradient along the length of cylindrical wire is this much, the current flowing through the cylindrical wire is this much, okay. So let's see in the solution and try to understand what exactly given. In the cylindrical wire, radius is given. So your wire is this, they have given the radius, okay. If they have given the radius to be this much, so what is the given data we have? So the given details we have is the radius, that is 0.05 mm, or I can also write 0.5 into 10 to power of minus 3 meters. Then we have conductance. So conductance they have given, conductance is this thing that is opposite of resistivity. So 5 into 10 to power of 7 ohm meter inverse, okay. If the potential gradient along the cylindrical is this much, potential gradient along this means dV over dl they have given, that is 10 into 10 to power minus 3 volt per meter. The current flowing the wire, is this value. So the current which is flowing is x to power of 3 times pi, and this whole value is given into 10 to power of minus 3 ampere. Then they are asking what should be the value of x. So if you remember guys, what is the conductance, what is the resistance, so even if you don't remember the direct relation, I am going to give you very easy numerical and how can you derive and you can get your solution for this. So now see it very carefully. If you remember that R is equal to rho times L over A, this is everybody know. What is this? This is called the resistivity, and resistivity is opposite to the conductivity. So can you say this is going to be 1 over conductance over L over A, right? So can you say that this is the relation you have for resistance? Now for the voltage, we all know that voltage is I into R, and voltage is in this case is going to be I into 1 over conductance L over A, right? So you will able to get this relation in which you have the conductance, area, I, L, everything. Now what we have to do, they have given the dV by dl. dV by dl is means just differentiate this whole equation by dV over dl. You are going to get I into sigma over 1 over A. This is the relation you are going to get. Now in this case you have to find the value of I. So I can be written as sigma into A into dV by dl. This is what you can write. Now I is how much? I they have already given that x cube into this value. So let me write x cube into pi into 10 to power of minus 3. Conductance is given how much? 5 into 10 to power of 7. Area is how much? Area is going to be pi into R. R is this value. If I square this value, this is going to be, I guess, 0.25 into 10 to power of minus 6, and dV by dl they have already given, which is 10 into 10 to power of minus 3. So 10 into 10 to power of minus 3. So 10 to power minus 3, 10 to power minus 3, pi cancel out, right? Now what do we have? We have this value, so I can just replace this. This will be 100. If it is going on the top, it will become 8, right? So I have the 10 to power 7. So 10 to power 1, 10 to power 7 plus 1 will become 8. So this plus and this will cancel out. So I am going to have x cube is equal to 5 into 25, which is 125, and the cube root of 125 is going to be x equal to 5. So your answer has to be the 5 from this solution. Simple thing, you can derive the relation from here and you can differentiate and you get your result. Simple things you have to follow. You don't need to remember this typical formula. You can derive the formula and you can get your answer from different ways. This is called the short tricks, which I will be teaching you in these lessons so that you can remember all this question easily way. Okay, now the next question is from the KTG. KTG is what? Kinetic theory of gases. In the KTG they have given the RMS speed. So I hope you remember all the formula of RMS. So what was the formula for VRMS? VRMS is basically, normally we have, what is the formula? This is 3 RT over m naught. What is that? M naught is your molar mass. In this case they have given that at some velocity they have given at this thing. So VRMS they have given is 200 when their temperature, corresponding temperature is 27. So if I add 27 plus 273, why 273 boss? Because SI unit of temperature is Celsius, right? No, SI unit of temperature is Kelvin. So we have to convert all the, whenever we are doing some chemical properties or any relation, we have to convert the unit into the Kelvins. So that is why we are going to have only, this is 300 Kelvins. This is going to be my temperature in the first case when my velocity is this thing. In second case they are saying that its RMS velocity becomes x over root q. So VRMS in second times is x over r cube, and what is the unit? Meter per second. And at what temperature? This temperature. So this temperature is going to be 127 plus 273, which is basically equal to 400 Kelvin. This is my T2. Now whatever the pressure, they have given the pressure. So pressure has nothing to do. Why? Because we have already changed. Okay. So find the value of x. So we can place this in this relation and I can say these two values are the constant. So direct VRMS is directly proportional to the temperature, right? So from here I can say V1 over V2 will be equal to root of T1 over T2. Since I need the value of V2, V2 they have given V2 over V1. V1 was how much? 200 equal to T2 over T1. T2 is how much? 400. So 400 is going to be 400 by 300 and that will be in root of that. 100 gone. So V2 will be 2 by root 3 times 200. Now V2 they have given already, that is equal to x over root 3. So if I equate this value, this is going to be x by root 3 is equal to 2 by root 3, right? And we have already cancelled this, and this will 200 will also come over here. So root 3 cancel out, x will be 400. This is how simple thing you have to solve your numericals and you have to get your answer. Very good. Next question, again very important question, very easy question. LCR they have given the resonance power. Resonance power means when XL become XC. Okay, so resonance power they have given XL equal to XC. So basically whatever the power is derived, that is from resistance. We already know that. In this case they are saying that at resonance the total power is 16 watt. Okay, and voltage, source of frequency 10 to power, this has to be 10 to power 5 at this much voltage. So voltage they have given that is 120 volt, and they are asking find the resistance of the circuit. So if you remember that LCR circuit, when there is a condition for resonance, so at the condition of resonance XL is equal to XC. So when whatever the resistance offered by the capacitors, that is equal to the resistance offered by your inductance, in that case only the power is driven from the your resistance, right? So the power formula will come simple. So power equal to V square over R. We need to find out the value of R, so it will be V square over P. V is how much? V is already given, that is 120. So I can say 120 times 120 divided by power. Power is how much? Power is 16. So for 16, this is going to be the value of resistance. And if you solve the relation, what you are going to get? 16. So if you subtract from 4, divide by 4, it is going to be 4, and if you divide by 4 it will be 3. If you divide by 4 it will be 3. So R is going to be 30 times 30, which will be your 900 ohm. So your answer has to be 900, and what they have given, no, it should be 900 ohm resistance. Understand? So this is how you can solve. You need to remember that at resonance, the resistance offered by inductor is equal to the resistance offered by the conductance or your inductance. So because of that, it is equal, and we will able to use only resistance. Okay. Now, if you see that so many questions, whatever we are discussing every day, we are taking some classes, we are uploading the recording classes, and we are taking the live classes as well. If you see that so many questions are directly coming from our slides. Okay, if you review my modern physics lecture, you will be able to see all type of questions which we have uploaded there. So if you're coming to our app, and if you're downloading, if you're just using this question bank which has so many question banks, same type of question bank we have already uploaded on our app, if you're able to access that, if you're able to solve that, these materials are only for you, so that you guys can improve your rank, and you guys can secure your seat into one of the prestigious universities across India. So no one can stop you unless you are stopping yourself. So what you have to do, you have to come and you have to start looking for the question. You have to start practicing the question, ask the doubt. We are always help for all the time. It is only you who has to do the hard work, and if you are ready to do the hard work, we are always with you. Okay, so what are the benefits that we have is the simple, you can solve so many questions, entire syllabus is there, so many, the faculties from IIT and IITs are teaching you, and they're taking you in every way, they're taking you doubts, they are providing you the after class practice sheets, so that you can understand your logic and you can solve as much as question requires, so that you can be one of the person who is going to make your dream come true. Okay, so try to avail the course, try to go for that. These are the, definitely we are doing the crash course on this JEE Main. Every day we are uploading, at least we are coming live for you guys, so that you guys can ask as many as questions you want in your chat box, messages, everything is open for you. It is only you who has to take this advantage, and it is only you who has to download this app. You have to practice and let us know what we can extra offer for you. Thank you very much for joining our session. Thank you very much. सही बोला ना?